All right, so today we are working on multiplying polynomials. I know that we went over FOIL briefly in class, but I'm not confident on the others, so I want to make sure you take the time, watch the video. I'm going to get started on the first example, and what I'd like you to do is pause as we go and try the others. For the FOIL method, I want to point out it says here it's only for a binomial times a binomial. You can use the logic of this for any multiplication with polynomials, but it really only works for the acronym with binomials. So I know what we went over in class, but in case you forgot, it's first, outer, inner, last. So it gives us an order for how we want to multiply. Here, if I look at the first terms, that's x times x. We're going to get x squared. My outer terms is x times 5. I'd get 5x. My inner terms, 2 times x would be 2x. And my last terms, 2 times 5 would be 10. And then this note here, multiply for each letter, always add O and I. It tends to work out that we're going to be combining like terms there. So the result of multiplying those binomials is going to give us the trinomial x squared plus 7x plus 10. So again, if you want to pause and try the other two, number 2 should be pretty simple. Number 3, you just want to be careful with that negative. So pause and try those in some scrap paper. When you're done, when you're back, I want to move on to the table method. This is also commonly referred to as the area model. The idea that we can figure out if it's a 2-term by 2-term multiplication, what's the result of that? So I like this because it can be nice and neat. Once you get into more advanced problems, it gives you some organization in the work. Some people just find this to be an unnecessary step. If I have 2x minus 3, you'd write it over here, times x plus 5 on the top of my grid of my area model. And then I just find the area of each. I multiply x times 2x to get 2x squared, 5 times 2x to get 10x, negative 3 times x to get negative 3x, 5 times negative 3 to get negative 15. Then we skim the problem, see if there's anywhere we need to combine like terms. We'll have to combine negative 3x and 10x. So the final answer, 2x squared plus 7x minus 15. Once it gets into trinomials, that's why we sometimes want other methods, just because FOIL doesn't work anymore. We don't have that acronym, and it can be helpful to break down a little bit more clearly what should be a negative times a negative and keep track of sign. So take a minute, pause, try problems 2 and 3. All right, this last one, it's called the Wiley branch method, which I've honestly never heard before. I always kind of refer to this as an extended distribution. Really carefully, just like we would with FOIL, saying, all right, if I have this first term, create branches. X has to go here and be distributed there. So those first branches, x times x squared, we'd get x cubed. X times 5x, we'd get 5x squared. X times 8 plus 8x. I'm going to change colors for the other branch. If I also need to distribute 1 here, here, and here, 1 times x squared, I'd be adding in x squared. 1 times 5x, I'd also add 5x. 1 times 8, I'd also add 8. So one thing you might notice, this time I tried setting it up more like columns, so that when I go to combine like terms, there's nothing to combine with x cubed, but it's really clear that 5x squared and x squared is going to add up to 6x squared. 8x and 5x is going to add up to 13x, and I'll have a plus 8 at the end. So one kind of common pattern, if my largest polynomial was a polynomial of 3 terms, we often end up with a polynomial of 4 terms. So again, pause, try the next problem, a little bit trickier. Be careful with your handwriting, but otherwise you should be good to go. For any of these problems, you can use whatever method you prefer. I recommend that you try them all throughout your work today, but it's totally up to you.